In this video I will show you how to build a retractable EDF for the 3D printed DFS Habicht. Links to the 3D files are in the description. This upgrade gives you all the versatility of a motor glider while keeping the fuselage look scale with no ugly propeller at the front. When retracted, the EDF is completely hidden, but when extended it has more than enough power. It's definitely the coolest way to power this plane. It looks great, it flies great, and it also sounds great. But there are also disadvantages. The weight increases by 35% and the added weight is only in the fuselage, which means that the wings must hold up to much higher forces. The maximum G loading decreases from 8G without EDF to 6G with EDF. To give you an idea how this looks in action, here are a few clips flown with EDF and without EDF. As you can see, the plane can do all aerobatic maneuvers even with the weight of the EDF. However, you will have to fly a lot more careful. With the added weight in the fuselage, the plane will pick up speed a lot quicker and generally fly faster. Always keep an eye on your speed. Stall characteristics are very gentle, both with and without EDF, and the slow speed handling is fantastic. This is a scale aerobatic glider and it has to be flown like a full-scale plane. All aerobatics in these clips are flown with motor off and EDF retracted. And now the flights without EDF. The plane is now a lot more forgiving. Not as fast, but a lot more elegant. To be honest, I'm enjoying to fly without EDF a lot more. But because it's 3D printing, you can always build multiple fuselages for multiple situations. And now let's get to the build. Use the build instruction of the DFS Habicht as a base. Here's a list of required parts and print settings. Build the wings first, that way you can find the best tolerance for your spar box. After gluing the spar box together, remove these supports. Now glue the gear onto the spar box. Reinforce it with a bit of extra glue for extra stability. This system was designed for 64mm EDF units from PowerFun and FMS. Solder extension cables to the EDF unit to get to a length of 30 cm between EDF and ESC. Put the EDF into the EDF shell like this. Now put the inlet ring back on. To remove the EDF again, take off the inlet ring first. Now let's move on to the arms. Upper and lower arms are printed with supports. Make sure to remove all supports and also all stringing that comes from support. You can also use sandpaper to smooth it a bit. Here are all the parts you need for the next step. Use the small washers to connect the upper and lower arms to the middle arms. On the upper arm right, use the potentiometer holder instead of a washer. Its location can be seen by the little square. Use these graphics as a reference to screw everything together in the right way. The flat side of the potentiometer holder must face the angled side of the upper arm. Now attach the arms to the spar box with the large washers. They must be just tight enough so that the arms can move freely without play. To find the perfect tightness, over-tighten the screws a little bit and then release them just as much so that gravity can pull the arms down. Now screw the EDF in the same way. The upper EDF screws must be a little bit longer than all the other screws. Here are the dimensions. You only need 2 of these screws. Now the EDF should move easily up and down. You can see how the arms touch the spar box in the upper and lower resting positions. Now screw the worm gear onto the worm holder with another washer. To get it in between the arms, release this screw. Screw the worm in like this. Now put this screw back on. You should now be able to move the EDF by turning the worm gear. Now let's motorize it, and to do that we need a 9 gram servo. Plug the servo into the receiver channel you want to use for EDF retraction. For me that's channel 8. Set up a 2 or 3 position switch as the channel input. I highly recommend to slow this channel down to about 2 seconds if your radio allows this. Slowing the servo down greatly increases the lifetime of the mechanism. Now we have to take the servo apart to relocate the potentiometer that's in it. The potentiometer is an electronic component that allows the servo to know its position. By relocating the potentiometer to the joints of the arms, we can gear the servo down even further with the worm gear, and that way we get the torque to move the heavy EDF up and down. This piece connects the servo horn to the potentiometer. It has a flathead like a screwdriver, which goes into this hole and grabs into the potentiometer. There's a little bit of plastic on this part which prevents the servo from turning further than 360 degrees. Remove this. Now carefully take the servo further apart to reveal the potentiometer. It is the green and white part. It can have other colors than green, but the center is usually white. Here you can see more clear how the servo arm adjusts it. Now cut the potentiometer off, but make sure to leave enough of the connectors on both sides. Now solder the 15 cm servo extension cable between the potentiometer and the servo board. Make sure that the pins connect to the same position where we were before. And now if we plug everything back in and turn everything back on, something interesting happens. We can actually adjust the motor speed by adjusting the potentiometer. Turn the potentiometer until the motor stops. The position where the motor stops depends on the channel value. Now increase the size of the servo cable hole to make both servo cables fit through. Put the servo back together. The next step is a safety precaution. Set the end points of the retractable EDF channel to 10%. That way it won't crash into something when we build it into the retractable EDF. Now adjust the potentiometer until the servo stops spinning. It will start spinning again when you flip the switch because the channel value changed. Now turn the arms roughly to the midway point. And now comes the hardest part, installing the potentiometer on the arms. The pins of the potentiometer must point in the same direction as the flat side of the potentiometer holder. Be careful not to glue any moving parts shut. The potentiometer must also be connected to the upper arm right, and these two parts should not have any play, they must be a solid unit together. Make sure that the rotation axis of the potentiometer is exactly in line with the rotation axis of the arms, and that the white disc is never more than 45 degrees away from the spot where the rotation stopped. Now put the potentiometer adjuster in. There's a little hole in the middle arm where the potentiometer adjuster can go in. You might have to cut a little bit off of the potentiometer adjuster depending on the potentiometer in your servo. Here's a graphic of the two moving groups to help you indicate which parts should move together. Screw the servo arm onto the worm gear and then screw the servo in. If there is a gap between the servo and the worm gear, you might need to use the worm spacer. Now it's time for testing. Turn your radio on, but when plugging in the battery, make sure that you can immediately pull the plug back out in case something goes wrong. The arms should now move close to the 45-degree position and then stop. If they do not stop, immediately pull the battery out. When flipping the switch, the servo should now move just a little bit because we set up very little rates earlier. To set up the full range of motion, increase the endpoints again. Do this for each switch position individually, so that the arms move when you adjust the endpoints. The arms must touch the spar box in their up and down position, but the servo motor should not make any noise. Here you can see that the arms cannot reach the lower resting position. That's because in OpenTX radios the range of motion is limited to -100 and +100. You have to go into the menu and check the box Extend Limits. Now you can go further than 100% and set your proper endpoints. Screw the EDF back in. Also tighten all other screws. Make sure that the cables can't get in the way of any moving parts. Here you can see how I have glued them down. Before applying any glue, test if the cable position works throughout the entire motion range. Now it's time for a final test. Check all screws and all connections, and if there are loose screws or loose parts, use glue to put them in their place. One last very important thing. I forgot to do this during the build, but you should definitely do it while the EDF is still out of the fuselage. Put some grease on the gears. That way the servo won't have to work as much. It will also greatly increase the lifetime of the system and the reliability. You can always add new grease later. Now follow the instructions to build the fuselage, but replace the spar box with the EDF assembly. Glue the two carbon fiber rods into the holes in the spar box. Slide fuselage 4 over the carbon fiber rods and over the EDF. Always test fit all parts before applying any glue. Now glue the fuselage part in place. Make sure that no glue gets into the pushrod channels. The spar box must be glued in as good as possible. Add glue between the parts to close all the gaps and wipe away excess glue with a paper towel. One last test before closing the EDF. Put the elevator and rudder push rods into their channels, that way the parts will align perfectly, but make sure to not glue them down, because they have to move. Slide the front EDF doors over the upper carbon fiber rods. And now fuselage 5. Glue it down if it fits well. Now glue the hooks on the rear EDF doors like this. Hello there. Also slide the rear EDF doors on and glue them onto the front ones. You can use this landing gear piece to prevent the fuselage from falling over. Now add fuselage 6. The rear EDF doors rub against the fuselage while closing. Use sandpaper to make the doors close smoothly. Now put a rubber band between the hooks. It must have the right tension to keep the doors closed, while also being loose enough so that the EDF can push the doors open. Attach your ESC to the electronics board. Make sure that the motor and servo cables have enough room to move when the EDF is moving. The EDF should never turn on inside the fuselage. I highly suggest you to set up your EDF extension switch as a throttle arming switch, so that the EDF can only turn on when it is extended. When built from lightweight PLA, a 2600 mAh 4S LiPo moved all the way to the front should be enough to get the right CG. The cables should run in this kind of loop so that they can extend when the EDF extends. And now finish the build and go flying.